All right, so as promised, we're going to discuss the stability of equations. Now, stability is where the solutions tend to in the long term. So you'd have a couple of points which have derivative 0. So this point here are called, or points called critical points or fixed points. Fixed points because they don't move in time. If you're at a fixed point, you can never move because your derivative is 0, there's no change, and you never move off that point. What's interesting is to see the long-term behavior of solutions which begin near critical points. So obviously the critical points for the logistic equation P equals 0 and P equals capital K. Here capital K is equal to 1. Now we saw in our last or in previous videos, we've seen the slope field. And we've drawn trajectories. If we start here, which is close to the critical point P equals 0, we find that our solution rapidly diverges from that critical point. Right? Even if we're down here, right? If we extend our slope field, and you can check this, the derivative looks like that. The derivative is negative on the other side. If you start here, right, assuming you can have a negative population, of course, right, P no longer represents population, but it's just some variable. The solution diverges from that critical point. We call this critical point unstable. Whereas, if we start on either side of the top critical point, P equals 1 in this case, we find no matter where we start, we end up at that point. We call that a stable point. So stable is attracting, unstable is diverging. Now, we can actually represent these solutions a bit better on what's called a phase line. So this section, I've just drawn in a random cross section at some t. We depict the critical points as dots upon this phase line, and we use arrows along the phase line to show where the trajectory heads. So the trajectories move away from an unstable critical point and towards a stable critical point. This is related to the sign of the derivative. dp dx is positive here, dp dx is negative in these regions. So this is how we draw a phase line. We work out where dp dx is, dp dt. Apologies. We work out where dp dt is positive and negative, and that's actually really easy. This thing here is an upside down parabola. It's got root 0 and 1, and it looks like that. So, step 1, draw a line. Step 2, draw the dots for where the critical points are. Step 3, sketch what the derivative actually looks like. It's positive here. It's negative here. In the regions where the derivative is positive, so here, this region here between the two dots, derivative is positive. That means arrows move from left to right. Here, our derivative is negative. Arrows move from right to left. And so you see quite quickly that solutions will diverge. Solutions trajectories move away from this critical point and move towards this critical point. So we can classify these critical points as unstable for p equals 0 and stable for p equals 1.